All right, in 9.5, we're going to deal with exponential equations and applications. And this is really important. It wants you to give us an exact answer and round to 3 decimal places where necessary. So your exact answer may be in the form of a log, and then you will want to put that in your calculator. But you also have to look at this and see, well, what kind of problem is it? There are a couple of different things. Um, can I put both sides of the equation as powers of the same base? Or if not, how do I get that out of the exponent? Well, I'm going to have to take the log of both sides. All right, so you might want to go back and review the rules for that. So if I have 1/2 to the x equals 5, they are not, I can't write 5 as and 1/2 as a power of the same number. So I'm going to go straight to taking the log of both sides. Now there are a lot of different ways that you can do this. You can either just use log base 10, natural log, or you can use this as your base. It doesn't matter. So I'm going to do this one both ways. So I'm going to take log base 1/2 of 1/2 to the x equals log base 1/2 of 5. Well, log base 1/2 of 1/2 to the x is just x. And that equals log base 1/2 of 5. Now, you can put that in your calculator as is, or if you need to use the change of base, this is the log of 5 divided by the log of 1/2. And then if you get your approximation for that, you get negative 2.322. So this is your exact. This is the decimal approximation. Now I'm just going to show you on a separate piece of paper. I don't think I have room here. I could do this by, if I have 1/2 to the x equals 5, I can take the log of any base of both sides. Well, from here to solve this, I would have to take this and move it around front. So that means x times the log of 1/2 is equal to the log of 5. And I keep forgetting to put parentheses in there. So to get x, I'm going to divide both sides by the log of 1/2. So x equals log of 5 divided by the log of 1/2. Now, do not confuse this with this being something that you can condense or expand. But notice, if either way you do it, you get the same thing. So whatever you're comfortable with, there's not any one way that's right or wrong. Okay, well, let's see. If I can get, I've got e here. If I can get the e to the x plus 1 by itself, then I can take the natural log of both sides and I'm golden. Okay, so let's go ahead and do that. So I'm going to divide by 2. And I get e to the x plus 1 is equal to 17 over 2. Okay. So now I'm going to take the natural log of both sides. Well, the natural log of e to the x plus 1 is just x plus 1. So x plus 1 equals the natural log of 17 over 2. So x is the natural log of 17 over 2 minus 1. So again, that is your exact answer. And then x is approximately 1.140 when you put that in your calculator. And that is the decimal approximation. Okay, now, the first thing I notice here, and this is why it's really good to know your powers, 4 and 8 can both be written as a power of 2. So I can write 4 as 2 to the second to the x plus 1. 8 is 2 to the third to the 2 minus x. One of our rules is if the bases are the same, if this is a true statement, then the exponents have to be the same. So this gives me 2 times x plus 1 is equal to 3 times 2 minus x. 2x plus 2 is equal to 6 minus 3x. So I'll add 3x and I'll subtract 2 from both sides. So that gives me 5x is equal to 4. So x is equal to 4/5. Or you can write it as 0.8. Okay, if I have 6 to the x minus 3 equals 1 over 36 to the x squared. Okay. All right, well, let's see what I got to do with this. All right, I know that this can be written as 6 to the x minus 3. 1 over 36 is 6 to the negative 2 to the x squared. My bases are the same, which means my exponents have to be equal. So I know x minus 3 is equal to negative 2x squared. This is a quadratic, so to solve it, I'm going to set it equal to 0. So 2x squared plus x minus 3 is equal to 0. This factors into 2x and x. Plus 3 and minus 1. So this tells me that x equals negative 3 halves, or x equals 1. Okay, this one is very similar to B, where if I can get the e to the x plus 1 by itself, then I'm golden. So I'm going to start out by writing this as 3e to the x plus 1. If I add 4 to both sides, is 12. If I divide by 3, I get e to the x plus 1 is equal to 4. If I take the natural log of both sides, this becomes x plus 1 is equal to the natural log of 4. So x equals the natural log of 4 minus 1. This is my exact. And my decimal approximation is 0.386 for my decimal approximation. Okay, let's see. If I can get this isolated, then to get this out of the exponent, I can find a log of both sides. Okay, so the first thing I'm going to do is add 8. So this gives me 5 times 4 to the x plus 7 is equal to 50. When I divide by 5, I get 4 to the x plus 7 is equal to 10. So I'm going to take the log of both sides. So the log of 4 to the x plus 7 equals the log of 10. Oh, oh, I wasn't even paying attention. This is awesome because the log of 10 is 1. So I can move this around front. So this becomes x plus 7 times the log of 4 is equal to 1. So let's see. I can split this up and write this as um, x log 4 plus 7 log 4 is equal to 1. And I'm trying to get the x by itself. So what I'm going to do here is I'm going to subtract this. So I get x log 4 is equal to 1 minus 7 log 4. And then divide by log 4. So I get that x is equal to 1 minus 7 log 4 divided by log 4 is my exact. And this is approximately negative 5.339. Alrighty, so let's see. How long does it take money to double at 6% interest compounded annually? Okay, so let's see. We know from this we're going to be, if it's compounded annually, it is going to be A equals P times 1 plus R over N to the NT. If it's compounded annually, that means N equals 1, R equals 0.06. And how much long does it take for the money to double? Well, if I start with P, double would be 2P. So my equation becomes 2P is equal to P times 1 plus, and since N is 1, 0.06 to the T. And that's what I'm looking for. I want to find T. Okay, so let's see. I've got to get to the T. So let's see what I can do. Let's get rid of the P first. So that gives me that P is equal to 1 plus 0.06 to the T. And I'm sorry, that's not P, that's 2. Okay, well, let's start. Now we can just start taking the natural log. Okay, so, or I can even add these together. So this becomes 2 is equal to 1.06 to the T. Alrighty, so what I'm going to do is just take the log of both sides, and I didn't leave myself enough room here. So the log of 2 is equal to the log of 1.06 to the T. So this gives me that the log of 2 is equal to T times the log of 1.06. So this gives me t is equal to the log of 2 divided by the log of 1.06. And that becomes 11 point, but we're going to call it 12 years. How long does it take money to double at 5.5 compounded continuously? Okay, so this means I'm going to use A is equal to PE to the RT, where R is 0.055 and A, since it's doubling, is 2P. And we want to find T. All right, so I'm going to start out the same way. I'm going to have 2P is equal to PE to the 0.055T. Divide by P, so that gives me 2 is equal to the E to the 0.055T. I'll take the natural log of both sides, and that tells me that the natural log of 2 is equal to 0.055T. Now I'll divide, and that tells me that T is equal to the natural log of 2 divided by 0.055, which is approximately 12.603. We're going to call it 13 years. Because it doesn't quite make it in that 12th year. It has to go a little bit further. Okay. All right, let's do one more here before I switch videos. How long does it take for money to grow from 2,000, so that is your P, this is your A, R equals 0.048, and N equals 4? Okay, so I'm going to be using the formula A is equal to P times 1 plus R over N to the NT. And the only thing I don't know is my T. So I've got 4,500 is equal to 2,000 times 1 plus 0.048 divided by 4 to the 4t. All right, so let's divide by 2,000. So 4,500 divided by 2,000. So this gives me 2.25. And I'm going to go ahead and clean this up as well. 1 plus 0.048 divided by 4. 1.012 to the 4t. Okay, so now we can take the log of both sides. So I'm going to take the log of 2.25 equals the log of 1.012 to the 4t. So the log of 2.25 is equal to 4t. Oops, and I'm sorry, 4t times the log of 1.012. So now I'll divide by 4, 4 times the log of 1.012, 4 times the log of 1.012. And I'm going to bring this up here. No, t is equal to now the log of 2.25 divided by 4 times the log of 1.012, which gives us 16.996, but we're going to call it 17 years. We have to round up because it didn't occur in that 16th year. We have to wait. Okay, switch videos.